Hi, in this tutorial we're just going to go over acids and bases. An acid is basically a species that can donate protons into a solution. So what is a proton? Well, this is a proton. The proton, if we look at the hydrogen atom, just draw the atom like that, and I'll just draw the electron in red. Okay, so that's electron there. So that's a hydrogen atom as it stands. So it's not a hydrogen gas because that would be H2, this is just a hydrogen atom. Now if you imagine losing an electron from a hydrogen atom, that just leaves the proton in the nucleus. So H plus is often referred to as a proton. Okay, so that's why sometimes I'll call these protons. So really the hydrogen nucleus, it's a hydrogen that's been stripped of its electrons. Now that seems like a quite a strange thing, and we're moving away from chemistry because we've lost electrons, because electrons is really the essence of chemistry, moving more into physics. But no, we'll see how this doesn't really exist like that, because it has electrons given back to it by the solution. So that's hopefully what I'll show in a second. So if we just get rid of that, so a proton is basically a stripped down hydrogen atom. So we look at HCl as a good example of an acid. HCl is a gas. Now HCl as a gas doesn't donate protons because it's got a nice bond, and if you look at the bonding, if you go over structure and bonding of atoms, it's quite a polar bond. So there's chlorine there, and if you look at the what's called the distribution of that electrons, it'll look a bit like that. So most of the electrons are over near chlorine, and because it's more electronegative and it's pulling the electrons away. Okay, let's just get rid of that. So it's quite a polar bond. So what happens to that when it goes into water is that the HCl dissociates. It's called dissociates. I'll just write that down for you. So it dissociates. And all that means is it breaks apart when it goes into water. Now if you look at the little subscripts we've got here, we've got AQ meaning aqueous, and we've got G there meaning gas. So basically we're bubbling a gas into water, and as that bubbles into water, this molecule breaks apart into its component species of a proton and a chloride ion. Now I did mention how this could exist. I said I'd go over that. Well, basically if you look at water, basically AQ just means water, so we've got water in there. So look at the molecular structure of water, and what I'm going to do, I'm going to draw some lone pairs in, and don't worry too much if you've not come across lone pairs yet, but there are lone pairs on oxygen. If you do the Lewis diagram for water molecule, you'll see that there's some electrons left. They don't really do anything, they're just lone pairs, and they sit like that. And I've drawn these two little arrows here as one electron and there's the other electron. Okay, so what happens is we got a H plus around. And remember when I said that it's just a proton, it's just a nucleus of an atom. Well, if we've got a H plus here, then what happens is we get this lone pair, which is electron rich, so it's quite negatively charged, if you will, that bit, will donate its electrons into this hydrogen atom. And in doing that, the hydrogen atom actually believes, if you draw, I'll draw the orbital around it like that. You might not be able to see the edge there, but if you look at the vacant orbital, the one that's lost the electron, it still exists. It can exist. It can accept electrons into that orbital, and that's exactly what's happening here. Okay, so that first shell, if you will, the 1s shell, it will accept electrons into, and the hydrogen will actually believe that it's back into that state where it's stable. So that's all that's happening. So these H pluses don't actually exist on their own. They have these electrons shared with the water molecule, and that puts a slightly positive charge on the oxygen. So that is another way of writing that. Sometimes you'll see H3O plus. I'll just draw a little circle there around that plus so you can see it. Okay, so that's another way of writing this really, H plus AQ. So there's no free protons around, so we're still in the realm of chemistry. So we've managed to solve that one. So what is an acid? Let's go back to that because that's quite important. I'll just get rid of this and this. So an acid is basically a species, in this case molecule, so I'll write molecule. So it's a molecule, an acid. I'll choose black now. Is a molecule that donates protons into solution. Okay, so an acid is basically just any molecule or species that donates, that's very important, protons. So this HCl puts protons into solution. Now if you look at a base, let's draw this in blue because it will get a bit untidy. If you think of sodium hydroxide as a base, NaOH, and if we put that into this acidic solution, say, like this, what happens there, that's surrounded by water, what happens there is this base will mop up the protons, so you end up with Na plus, so you get the sodium ion going in solution plus water, and that's surrounded by water molecules again. Again, the same principles as before. The water will donate its electrons into sodium so it's stabilised, so it's not just floating around without an electron. And you get water, so basically if you look at the ionic equation there for this, you got OH minus once it goes into solution, plus H plus. Now they're going to find each other pretty quickly, and that will give you water. And I won't draw AQ because that's water is AQ. Okay, so basically you can see that a base, unlike an acid, a base, if I just move this up a little bit, and draw that in green as well. So a base, change my colour, is in this case it's an ionic species, so we'll write it as a molecule for now, but basically it's a species, and I say species because it could already be charged, if you will. So and that could be an ion. So I'll put it's a molecule or ion that doesn't donate, it accepts protons. So that accepts protons from solution. Okay, so the key thing here are that bases accept protons, or grab. That's a good word actually. So they'll grab protons. Okay, so they mop them up. And that's basically the difference between acids and bases. So an acid is a molecule that donates protons into solution, and a base is a molecule or ion that accepts protons from solutions. Now that's pretty much it for this introduction to acids and bases. I'll cover a few more topics and give you a few examples of good acids and bases and how metals react with them and things like that in future tutorials. So that's it for now. Bye bye.